so yesterday we did degrees. Today we're going to talk about radians. Word on the street is you guys did do some stuff with radians and geometry. Is that true or false? True. Okay, so from what I know, you just did some conversions. You didn't graph any of them. Today we are going to be making those angles, and this is going to be a no calculator section. Okay, so everything we're doing today is going to be without a calculator. So I often get asked, what is a radian? The best way for me to describe it is with an analogy. So in terms of the temperature, the weather outside, we can measure that in degrees Fahrenheit, or we can measure it in Celsius, okay? So similar to that, with angles, we can measure them in degrees, or we can measure it in radians. So a radian is just an angle measure, and it's based on the arc length. And you guys actually studied arc length in geometry, but I know it's been a minute. So it's based on the length of this arc. You guys remember doing some arcs in geometry? Okay, so it's still going to be, this is your value of theta. I know that this is kind of blurry here. It says theta equals 1 radian. Okay, and this is 1 radian. Okay, that is the measure of it. So arc length from geometry is like we did an equation that looked like this. We had the angle measure, we're just going to write angle. So whatever that angle was over 360, and then you multiplied it by the circumference. You guys remember what the equation is for the circumference? 2 pi r. Yep, so 2 pi times the radius. Okay, so the circumference of a circle with a radius of r is 2 pi r. So if you have an angle representing one full clockwise rotation, okay, one full time around the circle, that is 2 pi radians. Like your r value is 1. And you can use the fact that 2 pi radians is equal to 360 to convert angle measures between radians and degrees. We actually use the reduced form of this ratio. Okay, because if you have 2 pi compared to 360, okay, 2 goes into 360 how many times? What's 360 divided by 2? 180. Okay, so you guys can let me know if this is something you remember. So if you're converting from degrees to radians, you would take that value and you would multiply by pi over 180 degrees. Does that sound familiar or no? Multiply by pi over 180? Either nod yes or give me the big eyes. Sometimes. Yeah. Okay, so the other thing we're going to work with is the radians to degrees. Anytime you do the degrees, you do need to put the degree symbol. So we're going to multiply by 180 degrees over pi. Okay, so in this picture here, they are just emphasizing to you that this value of theta is 180 degrees. That is half of the circle. So we just said that the full time around the circle is 360. When you start, we talked yesterday how this is 0 degrees. 0 degrees is equal to 0 radians. Okay, this tells us that 360 degrees is equal to 2 pi radians, which means 180 degrees is equal to how many radians? Pi. And really, if we want to define half of this, isn't this half of it? If it was 90 degrees, can you guys tell me what the radians would be? Yeah, 1/2 pi, and the way that we would write that is pi over 2. So 1/2 of pi. 1 times the pi is what goes on the top. And we'll become more familiar with those as we keep working with these. Okay, and then that is your full 360, which is what they have. Okay, so if there's no degree symbol shown, you are just going to assume that it is in radians. Because if there's no degree symbol, the alternative is radians. So if you have a degree, you need to write the symbol. If there's no degree, the value is in radians. Now, most of what we are doing in this class, when we are working with radians, they are going to contain the pi symbol, but they don't have to. We're going to do, you're going to do more of that if you take pre-calculus or trig next year, where we do some radians without the pi. Okay, but most of them this year we are going to have pi in them. Okay, and so when you're writing this out, if it's a degree, okay, it needs this symbol. Because if not, it indicates it's radians. So that's the main thing you want to make sure you have in terms of symbols, okay? So if we're writing the degree in radians, for A we have negative 60 degrees, and B we are given 250. Okay, so if it is in degrees, we talked about how when you do conversions, you want the units to cancel out. So you can memorize these, but really, you can just use logic. If you want the degrees to cancel, the 180 degrees needs to be in the denominator so that the degree symbols cancel each other out, and then you'd be left with your radians. Am I going too fast? Is this okay? All right, so then we're just going to simplify. If I multiply straight across, I get negative 60 pi over 180, and then I just have to reduce. Are you guys like me where if it ends in a 0, you divide by the 10 right away to cancel that out? Yeah. And then you have 6 over 18. So 6 goes into itself 1 time, it goes into 18 3 times. Don't write it as negative 1/3 pi. We're going to write it as negative pi over 3. Okay, so if you need to adjust that, you can. Okay, it is the same thing as negative 1/3 pi, but this is how you write it. It's just like you're multiplying by this over 1. So you multiply the numerator by numerator, denominator by denominator. 6/18 is 1/3. Okay, and then you just don't leave the 1 on top. Alright, so I want you to try part B. Go ahead and multiply by pi over 180, and then simplify. Okay, so if we multiply by 180 pi on the top, our degrees are going to cancel, the zeros are going to cancel. Okay, so 25 and 18, do they have any common factors? No. All you're doing here is reducing fractions. Okay, and then when we move on to example 2, we're going to write each one in degrees. So make sure you have your degree symbol. So this one says 2 pi over 3 radians. Okay, sometimes they're going to have the radians, sometimes they won't. In fact, the next one we're going to do is negative 7 pi over 2. That one doesn't say radians. It doesn't matter. If there's no degree symbol, it is radians. Okay, so when you are multiplying, pi on the bottom, we can cancel out because anything divided by itself is what? Anything divided by itself is 1. Yep, okay. So you can decide how you want to simplify. Hey, I think it's pretty simple to double 180. What's that? 360. 360 divided by 3, 120. Because what's 36 divided by 3? 12. Then you just put the 0 on. Okay? Alright, and then we have negative 7 pi over 12, or sorry, negative 7 pi over 2. So we're going to multiply that. Again, you'll see I always write the bottom number first, and that's because when I'm doing this, I'm thinking, oh, what do I want to cancel? So if I want the pi's to cancel, the pi has to go on the bottom. Now, I don't want to do 7 times 18. I could. 7 times 10, 7 times 8. But can I just divide first? The 180 divided by 2? What's 180 divided by 2? 9. And then I can just do, what's 7 times 9? Yeah. And then put the 0 on there. Don't forget your negative. That's your final answer. Alright, any questions on that first part? Okay, now we're going to get into more of the radians. So let's remember yesterday how we found the coterminal angles. Remember coterminal angles end in the same position? Yeah, how would we find that? Yep, you added 360 or you subtracted 360. So now, let's think about that and apply it to this prediction. How do you think we're going to find coterminal angles in radians? Nope, well, we're going to plus or minus something. What? Yeah, 2 pi. Great. Okay, because 360 is equal to 2 pi. So we're just going to add or subtract 2 pi. Okay, and this is honestly not that bad. It's just going to be adding fractions together. So if you can add fractions, you can do this. So we're going to find measures of a positive angle and a negative angle that are coterminal with each given angle. Alright, so for part A, we have 4 pi over 3. So the first thing I can do is 4 pi over 3 plus 2 pi. So you've got to get a common denominator. So let's put this over 1, get a common denominator. Alright, so what's our, Silas, what did you get for your common denominator? Good. So we're going to multiply by 3 and by 3. So if you haven't done that, go ahead. And then some of you might be wondering how we can add pi's together. It's the same thing as a variable. You can treat it just like an x. So if you have 4 pi and 6 pi all together, you have, that's right, 10 pi. Okay, so 4 pi plus 6 pi, 10 pi over 3. Alright, did some of you venture on to the subtraction? Did some of you venture on to the next one? Because we need a positive and a negative. Did we find the negative yet? Nice. And then once you guys have found this, like once you know that this is 6 pi over 3, just, sorry, put added. So minus 6 pi over 3 is negative 2 pi over 3. And that's usually what I do. I convert it here, and then I just use that in the second one. Okay, for b, I have negative pi over 6. Negative pi over 6 plus, and then some of you might be able to convert it right away, that's fine. Or you might be able to do that part in your head, that's fine. Okay, so I'm going to give you a moment to find those. We are going to do the next one together. The diagram. Okay, and then Nemo, what'd you get when you added 2 pi? Sorry, you can tell me the number. Okay, so when you converted, what did you make this into? Okay, good. And then, so because this is negative, instead of adding the pi, we're just going to subtract it. 11 pi over 6. Great. And then, Nolan, what did you get when you did the subtraction? Close. Yeah. Yep. Great. And again, once you do that conversion, we're just subtracting that 12 there. Okay? All right, nice work. So we're going to do reference angles with radians. We're going to draw a diagram together that shows how we found the reference angle yesterday. So just like yesterday, we are going to be drawing out the angle. Just make your theta value somewhere in quadrant 2. Doesn't matter where for this part. We're just going to draw this diagram. Okay, so when we were finding the reference angle, we talked about how the reference angle is always the shortest distance to what? Good. Shortest distance to the, and we're filling in this blank, the x-axis. Okay, and so not the y-axis, always the x. So in our diagram, I just want you to show this is your reference angle. And if your reference angle is, if your theta values in quadrant 2 is always the shortest distance to the negative side of the x-axis, do you guys know what other quadrant will always give you the shortest distance to the negative axis? 3. Yep, 4 would be on this side. It'd be in quadrant 4, and the shortest distance would be the positive, just like in quadrant 1. There's a few things we want to remember about reference angles. They're always what? Positive. Great. Always positive. Okay. The other thing is that they are what types of angles? Acute or? Yes. Acute or right. Okay, so that means they are going to be less than 90 degrees. And then do you guys remember what we said that was in radians? Pi over 2, good. Or equal to 90, which is pi over 2. Alright, so we're going to draw a little picture to find the reference angle for negative pi over 6. Now, we are still getting used to the radians. Eventually, you will memorize this naturally. Okay, with very little effort, you will have it memorized. Right now, because we're just getting comfortable with those, we might have to write out the conversions for a little bit, and that's fine. So if you have negative pi over 6 times 180 over pi, you can convert that to degrees. Okay, and all you have to do is 180 divided by 6. What's that going to be? Negative 30. Okay, so we're going to graph negative 30 here. Because it's negative, we go clockwise. And again, you can estimate, I think most of you have straight edges. If not, it will come around with some straight edges for you. Okay, so keep in mind that our theta value here is negative pi over 6. That is equivalent to negative 30. Now, you have two choices for the shortest distance. It's either going to be to the positive x-axis or to the negative x-axis. Which one's the shorter? To the positive or the negative? Positive. Great. So can you guys tell me what the reference angle is? Yeah. Okay, and how do we write that in radians? 30 degrees is pi over 6. Okay, so we are going to have to write them in radians today. Okay, which I know that's going to take some extra effort, but everything we're doing is going to help us build some fundamental skills so that when we get to some of the harder trig stuff, it becomes a little bit easier for us. So we're going to be counting by radians today to find reference angles, okay? So there are multiple ways that you can do this. We are going to talk about them.
Teachers, please pardon the interruption. At this time, please release all varsity, baseball, and softball players.
So 4 pi over 3. How would you do this? So here's the graph 4 pi over 3. What do you guys think? Multiply, convert, and find that, okay? So, yes, you absolutely could do that. You could multiply by 180 over pi, and then you could think of it in terms of degrees. I'm going to show you another way to do that, okay? That's going to be less calculations, and it's going to help you for when we start to do something called the unit circle, okay? So, don't get that scared up. So, you guys are going to have to trust me a little bit, okay? I've been doing this for 17 weeks. And I don't look too young to been doing it that long, but it's true. Okay, so what we're going to do is we're going to do 4 times pi over 3. Okay, so this is going to help you because you don't have to do as large of a conversion. So with pi over 3, you are just going to multiply that by, I'll do it on the side. Okay, you're just going to do pi over 3 times 180 over pi. Going to cancel those out. 180 over 3 is 60 degrees. Okay, and again, if you get into a rut tonight and you're like, oh, it's too hard, you can always do what I just said. You can always convert it to degrees and then you can graph it. That is fine. Okay, but we can also that memorized. So if I just go 60 degrees 4 times 60 is what? 240. Okay, so we are gonna graph 240. You can also count by radians. You can count by 60 degrees. So if you can think about, hey, 60 degrees is about right here, okay, in terms of a circle, then if I go another 60 degrees, it's 30 to 90, another 30 degrees here. This would be 120. If I add another 60 degrees, where am I? Yep, 180. And if I add another, this is my 240. Okay, what we just did is we counted by pi over 3. This is 1 pi over 3. This is 2 pi over 3. This is 3 pi over 3. And this is 4 pi over 3. Again, as you start to do this, you are going to be thinking of it in terms of degrees. Most of you, that is okay. So what we did is we found this value of theta. That was 4 pi over 3. So pi over 3 is 60 degrees. It goes 60 degrees 4 times. And then we have to find the reference angle. So will you mark off what the reference angle is with 2 lines on your diagram? You don't have to calculate it yet unless you want to. Okay, so good. Your guys' pictures look good. So this was your reference angle. Okay, so can you see that we went from 3 pi over 3 to 4 pi over 3? What's that distance in radians? 3 pi over 3 to 4 pi over 3. What is it? Pi over 3. That's your reference angle. Okay, so your reference angle is pi over 3. And again, if you have to think of that as degrees for a little bit, fine. 60 degrees, pi over 3. Okay? Alright. Now we're going to try negative 7 pi over 4. So the first thing we're going to do is we're going to separate. So it's negative 7 times pi over 4. I think it's easier to just convert the smaller ones. Okay, remember with what we talked about earlier, remember how we talked about how this is pi, and then from there we said that this was half of that, pi over 2, because that was 180 degrees, that was 90 degrees, okay, what's half of 90? 45. What's half of a half? A quarter, right? A half times a half is a fourth. So this is pi over 4. So pi over 4 is the same thing as how many degrees? 45. Okay, it's based on fractions, right? If I cut this into fourths, okay, this would be 1/4. Based on that, do you guys know what this is in radians? 3/4, because we have 1, 2, 3/4 of the pi. See that? Ooh, move it along, this is all right. So this is going to be 45 degrees, and we're going to count 45 degrees, or pi over 4, 7 times, but we're going to go in a counterclockwise direction. Okay, you can also just multiply 7 times 45, that's fine. Okay, so if I go 45 degrees in the negative direction, it's half of this. So this is negative 1 pi over 4. This is 45 degrees. I'm going to go 45 degrees again, which is negative 2 pi over 4. I'm going to go 45 degrees again, negative 3 pi over 4, negative 4 pi over 4, and I want you to do the next three. So I want you to go to 7 pi over 4 using that counting method. Okay, so find what quadrant this ends up in. Alright, so let's see how we did. So this was negative 4 pi over 4, so we had negative 5 pi over 4, negative 6 pi over 4, and here is negative 7 pi over 4. Alright, so your angle is right here. That's your theta, negative 7 pi over 4. Okay, if you calculated it, what was your degree? Somebody calculate what your degree was? Negative 350. Okay, so now when we do the reference angle, it's the shortest distance to the x-axis. The shortest distance in quadrant 1 is to the positive side. This is your reference angle. What is it? 45 degrees, which is pi over 4. It is not negative. Never negative. Okay, so it's positive pi over 4. The distance from negative 7 pi over 4 to this is 45 degrees, which is pi over 4. Okay? Now the last one we're going to do is 14 pi over 5. So again, we're going to start with this split, right? We're going to do 14 times pi over 5, because pi over 5 is easier to convert. Okay, so if you're converting, and you're doing pi over 5 times 180 over pi, we end up having to divide those. And remember, this is a no calculator section. And this one really isn't that bad, because 5 goes into 18 how many times? 3. And then what do I do here? Going down to 0, and 5 goes into 36 times. So this is 36 degrees. Okay, now, counting my 36 degrees does not sound like a ton of fun. Also, I have 14 pi over 5. I know that one time around the circle is 2 pi. What would that be over 5? 10. Because what's 10 divided by 5? 2. So I'm not going to count all of that if I know that this is already over 10. So if I'm at 10 pi over 5, I have to go to 14. How many more do I need? 4. So what's 4 times 36? Let's do 4 times 30. 120. 4 times 6. 4 times 6 is what? Okay. Okay, so then I just have to go 144 degrees, okay, which you can estimate. I know that halfway here is how many degrees? Is it 135? Do you guys remember that from yesterday? We did one that was directly halfway. It was 135. So this is going to be slightly larger than that. It's okay. It's just a good estimate. So bad estimate? No. And then when you're drawing out the picture, just remember you have to do that loop around. So you have one full rotation. We end up here. So your theta is 14 pi over 5. So if this is 14 pi over 5 and I am at 144 degrees, remember, this is 180 degrees. What's the distance between that in degrees? 36, which is 9 over 5. That is for you to find out. So that's a good observation for these. Alright, so your day 3 homework, I want you to write this down and then I'll put up the